Hello, and welcome to 5 Minute Math. Today we are looking at the 6th grade STAAR test 2024, looking at lessons learned from that test. Specifically, we are looking at readiness standards that were assessed and received less than 60% mastery on the state level. So we are going to look at the items and then really think about what are the instructional implications, why did the students get those items wrong. So let's go ahead and get started. 6.2D in reporting category 1 was our lowest overall readiness standard. It was tested just one time, and we're ordering a set of rational numbers. And you see, even though this is a drag and drop, it's just a a 1 point item. You either get it correct or you get it incorrect here. And we had to order these numbers from least to greatest, and they had to get all 5 of these in the correct boxes. And you can see we only had 26% of our students get this correct. Now, we've got 1, 2, 3 items here that are negative. So without even doing any work, we should be able to put those items into these first 3 positions. And then we've got 2 items that are positive, so we should be able to put those in the last 2 positions. And looking at our 2 positive numbers, take a look. This one right here, this 46/24 is greater than 1, and this 35/52 is less than 1, which means I now know where these two go. 46/24 greater than 1 is going to be bigger than 35/52. So I don't need common denominators. I'm not even going to try to find a common denominator with 24 and 52. So I'm left with the 3 that are negative here. And we'll see that this is this negative 0.209, right? That has a 0 in the ones place, so it's a decimal. This has a 0 in the ones place, which is a fraction. But this has a 1 in the ones place, which means this is going to be our largest negative. Since it's our largest negative, that means it's the furthest away from 0. That means it's going to be our least number. So now I'm only left with these two right here. So that's not too bad. So -1/8. We need to know that our eighths, right? If we multiply them by 125, we can get up to thousandths. So 125 thousandths. Probably the easiest way to do this. So this is -125 thousandths or -0.125. So this -125 is going to be closer to 0 if we imagine our 0 being right here. So we're going to put our -1/8 here, -0.209 here. So that's the correct answer. And you can see only 1 out of every 4 students, roughly, got this correct. So what made it difficult? Well, we had to consider positive and negative numbers. We had fractional form. We had decimal form. And some students might have done all the work correctly and still struggle to order negative numbers. They might not know that the greater the negative number, the farther away it is from 0, which means the less it is. So these white text at the bottom is going to be our instructional implications. What can we do to help our students through this? Well, we need to really focus on that number sense. Think about how I started this, and I was able to sort 3 out of the 5 items without doing any conversions. That's just number sense. So rather than strictly focusing on how to change a decimal to a fraction, fraction to a decimal, percents, all of that, let's focus on number sense. Give our students practice of ordering numbers that should be ordered without any type of conversions or any type of common denominator. And then we need to practice these open-ended sorts using a number line. Just as simple as this. Pick 5 numbers between they're fairly close to each other, right? So between -2 and 2, put them in different forms. Just have the kids sort. That's a real quick activity that you could do coming into the classroom or at the end of a class period. Next, we've got 6.8D. This is in reporting category 3. We had 35.5% overall mastery. Now, this was tested twice, and one of these was not that difficult. One was extremely difficult. We're determining solutions for problems including area and volume. So even though number 32, we'll start with this one first because this one was scored a little bit higher. Even though that was a new item type, right? This is a text entry that a type in their answer. Look, they're looking for the volume. And in this case, the best one to use would be volume equals length times width times height, right? The other one is volume equals base times height. And the confusing thing here is that we need students to equate base is length times width. In this case, since it's a rectangular prism, base could be something else later when they start finding the area of a cylinder, for example. So we're just multiplying 5 times 3 times 1. Or the base would be 5 times 3 and then multiply that by 1. But one of the factors is 1, so it's just multiplied by itself. So that's just going to be whatever that answer is. So 5.5 times 3, right? That's going to be 15, and that's 16. We need that decimal right there, so it's 16 and 5/10 is going to be the answer on that one. And we had 52% of our students able to get that. Now, it was number 7 that really threw them for a loop. It is a basic rectangular prism, but look, they give us the volume. So let's go back and look at what they give us. Volume equals base times height. All right, so they give us the volume at 192, so I'm going to substitute in my 192 for my volume. The height right here is that, and then I've got a 4. Now, here's the thing. If students are just going to do this, and I'll do it incorrectly first to show you the most common misconception. All right, so this is going to be incorrect. If I just put in that 4 for the base, get the height, that's easy. Divide both sides by 4, and what do you get? H equals 48. That is the most chosen incorrect answer. But it is incorrect because that is not the base. That is just one of the dimensions of the base. The base is a square, which means if that's 4 and that's 4, 4 times 4 makes 16. So that's where it gets tricky. That 4 goes into the 192 really easily. But instead of saying 192 equals 4h, we need to recognize that the base of that square is going to be 4 times 4. It's 16h. Now that changes things. So now we've got to multiply uh, that 16 times something to get to 192, or we can divide each side by 16, and what you're going to get is that 12. So 12, or you just divide that 48 by another 4 if you wanted to do that. So our answer here is 12, but only 19% of our students were able to accurately get 12. So for number 7, 65% of our students chose A. So look at this. The incorrect answer, 65%, as opposed to, what did we get? 19%. So that's over 3 times as many. So that is a huge misconception that you can just take this 4 down here and use that as the base. So that is a major misconception for our students. They simply used that one dimension, and it was simple decimal multiplication for number 32. So looking at the text in white, what are the instructional implications? Well, we need to build flexibility with both formulas. This is the most efficient way to write it, but this is how it was introduced in 5th grade. And honestly, for that second item, that number 32, this one was made a little bit more sense because there were 3 dimensions on the screen, whereas on the first item, this one might have made more sense because there was just those 2 dimensions on the screen, but they still have to know that the length times width is what is replacing that b right here. And if we want to really cement this, we can show how v equals bh can be used for not only rectangular prisms, right, but we can show them how it's used for cylinders or honestly any other type of prism. So if we want to show them how you could use it for a triangular prism, right, and we can say, guys, this v equals bh, the B keeps changing. So if we could cement that for them, they would look at that B a little bit different and they would really evaluate the shape of the base rather than just taking one of the dimensions. So next we've got 6.7D. This is in reporting category 1 and it is 36.7% overall mastery. It was tested 3 times. So this had an item that was originally coded with another standard, but then they switched it, so this ended up being 3 different testing and Let's start with number 15 because we did the best on this one. We're selecting two expressions that are equivalent, and hopefully we're noticing after examining all of this that you see that 5 times 1/2 p goes with this 1/2 p times 5. And then we're subtracting both, and that's fine. But then we're doing the 2 times 7, and that goes with the 7 times 2. So what this is really doing is this is really helping us understand the commutative property that when you have two different factors, you can switch the order, and the sum or the product does not change. You can multiply in any order, and you're good to go. So that was our easy one. The other two, number 6 and number 31, were a little bit more difficult. So which expression is not? Okay, so I don't know if that necessarily tripped us up, and it is capitalized, it is bolded, but what does it mean to multiply by 1/2? Okay, so we need to distribute this out. So we could say this is 1/2 times 6, 1/2 times x minus 1/2 times 6, because that's really what this is. This is the distributive property. But it's not so much that distributive property, it's how do we show multiplying by 1/2? Because multiplying by 1/2 is the same as dividing by 2. So we have to know that you can use the inverse operation and the reciprocal, and you're also getting the same thing. So you see how A doesn't work because I'm multiplying the 1/2 by the x, but I'm not doing anything to that 6. So that's going to be our correct answer because it is not equivalent. So 1/2 times x, this 1/2 times 6, they turned into 6 divided by 2. So we need to know that 6 divided by 2 is the same as 1/2 times x. So that's kind of a challenge there. And then this one right here, they simplified the 1/2 x. They put x over 2. So these two are the same. Multiplying x by 1/2 is the same as dividing x by 2. And then they just simplified that 6/2 over 3. Now this one probably messed them up is D. Is you can also take just the 6 minus x, that whole thing, and instead of multiplying the whole thing by 1/2, you can divide the whole thing by 2. Same thing. So really, this is more about understanding that multiplying by 1/2 is the same as dividing by 2. Then how does that work when you distribute that out to this expression, 6 minus x? Only 23% were able to get our correct answer of A. And then here we're trying to find the pair of expressions that are equivalent. And this one doesn't work because you can't simplify positive 5 and negative 5 if the positive 5 is being multiplied by that A. So that's not going to work. And this one right here, this multiplies the 1/5 times 5, right? But instead of leaving 1, it should leave an A because the 1/5 times 5 effectively cancel each other out, but it leaves an A, not a 1. And if you were going to do this, this is very good, except for these two positives, or these two negatives make a positive. So if that were just a net positive A or just A by itself, that would be good. So this is the correct answer here, right? Positive 8A, negative 8A, add them together. They effectively cancel each other out. You're left with 3A, but only 29% of our students were able to get that. So for number 6, the answer distribution was around 25%, and C was the most chosen at 32. So let's take a look at that. C was the most chosen at 32. But if your answer distribution is about 25%, that means what you get is a lot of guessing. Even this 23% that chose the correct answer, we don't have any guarantee that they know what they're doing. They might have just guessed correctly. So this is about the distributive property, number 6, but also it's more of what happens, how can you show different ways of multiplying by 1/2, right? Multiplying by 1/2 is the same as dividing by 2. It's the same as putting some type of fraction over 2, right? There's just so many ways to show multiplying by 1/2. That's what messed our kids up. So for number 31, A at 27, B at 29, and D at 29. So 27, 29, and 29. 27, 29, 29. So we also have a whole lot of guessing on this. So we could say that for the most part, our students really struggled with these equivalent expressions. And this one was, I mean, this was just, do you have 8a and a negative 8a? But this really has to do with simplifying like terms. So what can you simplify and what can you not simplify? And it comes around this like terms. So there's a lot of work here that needs to be done with our students. Um, and we needed the distributive property, the commutative property, adding negatives, and then like terms. So we need to study and name the properties in isolation and in a variety of situations. So they should be able to know the inverse operation, or the inverse property, the identity property, commutative, associative, distributive, how it works with multiplication, how it works with addition, subtraction, if appropriate, and then use them in a variety of situations. So rather than thinking they are just intuitive and students will kind of understand how the commutative property works, they need to be taught explicitly and named explicitly. It's a lot of vocabulary, but students need lots of practice with it. We also need a lot of practice generating equivalent expressions in addition to simply simplifying. Because even this one right here on number 15, right, only 58 got this correct, which is pretty good, but there was no simplifying involved. It was simply finding equivalent expressions. So sometimes it's not a matter of simplification, it's a partial simplification. It's just a matter of finding an equivalent expression because a property was used, like the commutative property or the associative property. And then we really need to spend as many ways as we can to show division. Right? We can show division by multiplying by a fraction. We can show division by long division by using the division symbol. We can also use division like by 9 divided by 3 by just making it a fraction like this. Right? There's all kinds of ways to show division, and they need to know. We do that with multiplication. They understand that if it's a 3a, it's 3 times a. They understand that if it's 3 parentheses 9, that means multiplication, but we might not spend as much time on all the different ways to show division. So next, we are looking at 6.12c. This is in reporting category 4. We had 37% overall mastery. So we're summarizing numeric data. We only had 37% correct. So we had this data set here, and it's a pretty straightforward data set. And it's 5, 1, 2, 4, 3, 9. And we need to look at the mean, median, the mean again, range, range again, median again, mean, and median. So we've got 3 things to do: mean, median, and range. All right, so we need definitions. So what is the mean? Well, the mean is, I always think of it as the average, which means you take the sum of the data and then you divide it by the number of data points. All right, so what is our sum? Well, we've got 5 plus 1 plus 2 plus 4 plus 3 plus 9. Let's make that a 9. Okay. Add all that together. So I'll do it here since I'm kind of running out of room. That's a 6. 6. That's a 12. So that's another 12. So that's 24. And how many data points do I have? 1, 2, 3, 4, 5, 6. Okay, so really that's going to equal, so the mean equals 24 over 6, which is 4. All right. So the mean is 4. So even just understanding that, we might be able to eliminate some answers. The mean and the median are both 4. Well, I know the mean is 4. The mean and the range are both 4. I know that. The range is 4. The median, I don't know. The mean is 4. Okay, so guess what? The mean is 4. That's the only option there is. So we didn't really even need to do that work. Median is our middle. So we're going to take our numbers. Now we need to put them in order. So let's put them in order. 1, 2, 3, 4, 5, and then 9 is way down there. Right? So that's definitely an outlier. Okay? So we've got this half and this half. So since it's 3 and 3, the exact middle is actually in between 3 and 4. It's the average of those two. What comes between 3 and 4? Well, sometimes the median is not even a number in the data set. It's going to be 3.5 or 3.5. Okay, so we can eliminate A because it says the median is 4, and that is incorrect. The mean and the range are both 4, I don't know, and the median is 3. That is incorrect. The range is 4, maybe. The median is 3.5, yes. And the mean is 4, and the median is 3.5. Okay, so both of D is correct, which means the range must not be 4. But let's look at our range. Range is going to be difference between the greatest and smallest. I've already lined these up here. So let's go ahead and use this. So greatest number minus the smallest number is our range. That's 8. That's why this is incorrect. All right, so our answer is D, and only 37% got that correct. So differentiating between mean and median, which are both measures of centrality, can sometimes be difficult for students because they're always going to be fairly close. Sometimes they even end up being the same number, but you calculate them differently. Once again, the median was not in the data set. It was between that 3 and that 4, so that still messes our kids up, is that your median can be a number that's not even in the data set. And then the choices for A, B, and C were a little less than 25% each. So when we're looking at, right, a little bit less than 20, so let's just call this about 20% each, right? Still a lot of guessing. A lot of guessing going on here, which means there wasn't a lot of calculation. Maybe they didn't, A, want to do the work, or B, didn't know the definition of any of these. But when you're looking a little bit less than 25% each, now you're looking at a lot of guessing. So what can we do as educators? Well, we can normalize, first off, that medians might not always be in the data set. So that might have thrown them off, who knows? We need to have them explain the similarities and the differences of the mean and median. So spend a lot of time between how are they very similar, their measures of centrality, how are they different, they're calculated differently, and then we need to calculate the mean and median to really show the difference, right, of extreme data sets, right? So look at the mean of this one. The mean of this one would be very strange because this would be 99, 100. This would be 103, right? Divided by 6. If you added those up, or actually divided by 5, there's only 5 pieces of data right there. So 103 divided by 5 is going to equal 20.6. Okay, that's our mean. Now, your median, this is a 5, so that means we have a central number is 1. So we can have some really rich conversations about how they're both measures of centrality. Some are useful, some aren't in certain situations. And in this case, that 99 being the outlier really skews everything for the mean. It doesn't skew anything when you're using the median. Things like that will make them remember the difference between the two and will help them understand them when they have to calculate both. Next, we're looking at 6.4H. This is reporting category 3. We had 45% overall mastery, one item, and we just had to convert gallons to cups. Now, the biggest challenge here was probably that initially we started with a decimal. Okay, so we need to know that our gallons, so I'm going to draw this right here. I'm going to put a gallon, I'm going to put 1 gallon, and then I'm going to draw like half of that, and I'm going to put 1/2 gallon. Okay, so I need to know that 1 gallon. Here's my first biggest challenge. Okay, 1 gallon has 4 quarts. So I'm just going to put a Q. I don't have space for a Q and a T. So biggest challenge is if 1 whole gallon is 4 quarts, how many quarts go into half a gallon? So we should be able to say, okay, that's going to be 2 quarts. If you can change your 1.5 gallons into 6 quarts, the rest is whole numbers. The rest is easy, right? Because then we know that each quart has got 2 pints. So now I've got 2, 4, 6, 8, 10, 12 pints. And then inside each pint, right, you've got 2 cups. And I'm not going to draw all of them, but you kind of see how we're working this here. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So 45% of our students were able to get this correct. And the initial conversion included a decimal. That was kind of the challenge there. And there was an equal distribution of other choices, around 18%. So that means we either understood this or we didn't. So it wasn't pure guessing because with 45%, a good chunk of our students, almost half, understood this. But when you've got this equal distribution right here, it lets you know that there's also some guessing. So we need to draw visual representations. You saw I drew a strip diagram. That's not the only way to do it, but that is going to help us keep track of conversions. This should not be straight numbers to where it's like, all right, so 1.5 times 4 equals 6 times 2 equals 12 times 2 equals 24, right? That's too abstract. A lot of our students are going to need some type of visual. And then we need to practice our conversions where the initial number, like 1.5 gallons, is a fraction or a decimal, not a whole number. See if they can figure out how many quarts are in half a gallon. All right, so we're looking next at 6.3D. This is in reporting category 2, 48% overall mastery. We're just adding, subtracting, multiplying numbers. And we've got this whole problem situation we really don't need because they give us the expression right here. So, which integer best represents the total change in value in gift card? Well, I've got the minus 30, so we're taking away 30. What happens when you add 2 times negative 7? Well, two sets of negative 7, right, is really like negative 7 plus negative 7. That's what this turns into. So if I add two negative 7s, I'm going to get negative 14. So now, if I bring this down, I've got negative 30 plus, I'll put parentheses so it doesn't look strange, negative 30 plus negative 14. So what we're doing is we're getting farther and farther away from 0. If we were to start at 0, in this case, we're not starting at 0. We've got a gift card, okay? But I can just represent this from 0, right? I can say this is negative 30. And if I were to do a negative 14, I'm going a little bit farther away. I'm going to end up at negative 44. We only had 48% of our students get that correct. And so we need to apply the order of operations to simplify the expression, right? We need to make sure we multiplied the 2 times 7 before we tried to add the negative 30 to the 2. And 25% of our students, so we did have a misconception here, chose A. So let's go back and look at A. 25% of our students got this answer, which means they didn't necessarily recognize this as multiplication because what they did here is they just did 2 minus 7. They thought this was a 2 minus 7, so that equals negative 5. And then they just added the negative 30 and the negative 5, and you get your negative 35. So 25% of our students didn't recognize that this is one way to show multiplication. So that's going to be a huge thing for our students. Just like earlier in the video, we were talking about all the different ways to show how to multiply by a fraction like 1/2. We need to show different ways to show multiplication. One of them is just two numbers next to each other with a parentheses in between. And a number line, like you saw me use at the very end, is going to be helpful when we're keeping track of negative and positive integers and which way the addition is going. That number line is going to help them. And we can also utilize all the different forms of showing multiplication, right? So we started with 2 times 9. Then we kind of graduated to 2.9. And then it's just 2 parentheses 9. So all of these show the exact same thing. And that's what students need to be very flexible with. All right, 6.6C in reported category 2, we had 49% overall mastery. We're representing given situations. In this case, we've got a verbal description. We need to represent it in an equation. Okay, so we've got the length of Miss Palmer's camping trailer is X feet. So I'm just going to put Palmer's camping trailer, X feet. Length of Mr. Guzman's camping trailer, Y, is 6 feet less than the length of Miss Palmer. Okay, so what it says here, that Mr. Guzman is Y, and it's 6 feet less. So I drew it shorter because Miss Palmer's X is longer. And what I could do is I can say, all right, so this distance is 6. Okay, so which equation best represents Y, the length of Mr. Guzman's feet? Well, Mr. Guzman's trailer in feet. Well, Guzman, you could say it's several things, right? You can say x equals y plus 6. But you see how I'm solving for x? I want to solve it for y. So how could I represent y? Well, I can say y equals, right? Since this is kind of comparative here, my larger number is the x, and then I could take away the 6, and then I get to my y. And you see that is our answer there. At D, we had 49% of our students get that correct. So this was a simple representation of, using an equation of a real world situation, but 24% of our students chose B. So let's go back and look. 24% of our students chose B, and we had 49% choose the correct answer. So they knew that something was subtracting, but you see how they just flipped the two, which you cannot use the commutative property for subtraction like you do with addition. So obviously those are not the same thing. So they were close. They knew there was some type of subtraction because it says 6 feet less, so they were able to pick that up. They just didn't know which came first. So drawing a diagram. And then what we could have done is we also could have chosen a value for Mr. Palmer's trailer, and then use that to verify the answers, right? So let's just say we just pick, okay? So if Mr. Palmer's trailer is 10 feet, right? Mr. Guzman's is 6 feet less, then we could say, okay, so that would be 4, right? So this wouldn't work in this situation. We couldn't say y equals 6 minus 4, or 10 equals 6 minus 4. That wouldn't work. It would work here. 10, or excuse me, this 4 equals the 10 minus 6. So sometimes we can just choose a value that's easy to calculate and use that to check our work. Next, we're looking at 6.5b. This is 56% overall mastery. We tested twice. We are solving real-world problems and then given a whole, part, and or percent to find the missing one. All right, so we had 54% choose correctly on 26, and so we had 40% of the trees. There were 500 trees. What is 40%? Okay, so really we're looking at 40% of 500. Now we've got a few options here. So we could just turn this into a decimal and we can multiply, right? That's always an option. Always change your percent to a decimal and then multiply. Okay, so that's going to be 2,000. Add that one digit behind the decimal, so it's going to be 200. So that's one way to do it. Now, you could also think of, if you were to think of 10%, right? So if you were to think of 10%, right, what is the whole thing? 500. So if I were to break that into 10 equal parts, I would get 50. So 10% is 50, 50, 50, 50. I know that 40% is the same as 4 sets of 10. The 4 sets of 10 is 50, so 50, 100, 150, 200. Right? You could use reasoning to get there rather than straight multiplication. If you could divide 50 or 500 into 10 equal parts. Now, this one was a little bit more difficult, right? Number 11, we had to have 20% had fewer, and then 80%, but here's the problem. You had 20 and 80. The 100 really threw kids off because there are 35 books. So what I need is I need 20% of 35, and then I need 80% of 35. But since the 100 pages was there and the 100 pages, then it's really easy to get 20% of 100. Oh, that's easy. That's 20. 80% of 100. Oh, that's easy. That's 80. And they use those two answers. So 20% of 35, right? We can multiply by 0.2, and that's going to get us 7. And then we can either multiply this by 0.8, or we could just take that 35, and we can subtract the 7. Either way, you're going to get 28. So that's what we need, right? We need that 7, and we need that 28. And you saw that 40% of our students were able to get both, and 11% were able to only get one. We don't know which one was chosen correctly, which one was incorrectly on that 11%. And almost half, 49%, got none of them right. So both of them, both of those items, which is not always the case, they were needing to find the part given a percent and the whole, which is probably the most common form of this, but obviously they need to be able to find the percent given a part and a whole, and find the whole given a part and percent, which is probably the most difficult. And then the less than 100 pages, the more than 100 pages were definitely distractors. So that threw some kids off. So that first item, we were able to use reasonableness to estimate solutions. We were able to get up to that 200 without even necessarily, without even necessarily calculating anything. And that reasonableness also could have helped us if, obviously, if we read this 35, look, if I chose 20 and 80, how do I have 20 books and 80 books? That's 100 books, but I've only got 35, right? So that doesn't make sense. And then visual representations might help, like I did right here, to kind of represent that 500 in addition to proportions if you need it, or if it's a given a percent and a whole and you need to find the part, multiplication is going to be easy for our students as well. All right, so we're looking at 6.11a. We've got 50.5% overall mastery, and this is reporting category 3. We are graphing. So we had 41% of our students able to get number 3. So we are given the height of a triangle, and it's 5 units. Okay, so which order? Now it doesn't tell you which direction. So I can draw my triangle like this. I could draw my triangle like this. I can draw my triangle like this, or like this. So all of those are a possibility. So let's just plot these points and see which of these would be a height of 5 units. All right, so 4, 2, 4, -2 is going to be right there. So that doesn't have a height of 2, 5. That's going to have a height of 1, right? 1, 4. So 1, 4. Okay, that could work. Let me see. 1, 2, 3, 4, 5. Okay, so this has got a height of 5 units. 6, -1. So that's almost off. That's just a vertical 5. That's not going to work. And then -2, 5. Now take a look at this. Very kind of similar to the previous one, but take a look. This is 5 from the x-axis. If you go from the x-axis to there, it's 5. But if you do the whole thing, it's 6. So our answer is B. But I bet you that's going to trip up some of our students. And then on this one, we literally just needed to select 2 points. Okay, -4, -3 goes right there. And then 10 units up, right? So that's going to be at 7, -3. This would then generate a line, and that's it. 2-point problem, 45% were able to get full credit, 29% were able to get partial credit. Probably they did fine on this one. They might have messed up the other one. And then 26% got no credit. They couldn't even plot that point correctly. So what does that mean for us as educators? Well, for number 3, 30% chose that D that we thought might be a distractor. When they counted up from the x-axis, 30% chose that, only 41% got it correct. So they knew they were close to the 5, but they chose on D, they counted up from the x-axis rather than counting up from the actual point, which is at -1, because that ended up being 6. And for 29, 1 point was for the initial placement, and then 1 point was for 10 units up. We don't know the partial credit students which one they got. So graphing in all 4 quadrants is new for 6th grade. And 5th grade, they only do quadrant 1. So practice, practice, practice. And then let's start low tech. Let's start with grid paper. Let's start using floor tiles and standing on intersections before moving to digital graphing. Because it's probably not the tech enhanced items that's throwing these kids, because this is a multiple choice. It's just the concept of graphing, which means we need to start slow with low tech before we go into trying to use all the digital tools. So next, we're looking at 6.4G, 51.5% overall mastery. So we're generating equivalent forms of fractions, decimals, and percents, right? So 48% of our students on number 21 were able to generate this 0.05, right? This is 5 in the hundredths place, so I'm going to write this as 5 hundredths because that 5 is in the hundredths place, and then I need to simplify. You can divide both sides. top and bottom by 5, you're going to get 1 over 20. Right, so that's our answer right there. This one, 3/8. Now take a look at this. 3/8. If you don't know how to figure out eighths, look what options you're given. 0.38, 3.8%, 38%. So that should have been your first clue, that there are only two blanks, but three of them are just 38. That's not how fractions work. You don't just take the two numbers and just put them into percent. So really, those three are incorrect, right? What we do is we multiply. Remember, eighths, I said earlier in the video, need to be multiplied by 125. We just need to have our students memorize that connection, because if you do that, you're going to get 375 over 1,000, or 0.375, which then turns into 37.5%. So these two are correct in whatever order you want. 47% got full credit, 16% got partial credit. Don't know which ones they got for partial credit. So for number 34, we had to, and that's the second one, we had to generate both an equivalent fraction and a percent. And eighths are not considered benchmark fractions. So when we're looking at 6.4F and benchmark fractions, right, we're talking about halves, talking about thirds, right? We're talking about fourths. Eighths are not considered a benchmark fraction, but as you can see already, we've had to convert eighths twice just in this video. So we should include eighths and the connection to 125 to get us into a quick fraction or decimal, right, that is equal to 1,000. That is going to help our students. Now, we multiplied that 3/8 by 125. You also could just divide up, right? Any fraction can be turned into a decimal by dividing the denominator into the numerator. That also works. Might be a little bit more work, but it works for students if they're comfortable with it. We're looking next at 6.4b, 56% overall mastery, qualitative and quantitative reasoning to solve prediction and comparison of real-world problems involving one of our biggest learnings in 6th grade, ratios and rates. All right, so we've got a ratio of science books to math books. Science books to math books is 4:3. So I'm going to draw this. So I'm going to put science books. I'll change colors here. Math books. Just do this. Math books is 4:3. Now, there are 36 science books. All right, so let's go back to this. So if this is 36, well, how many rows would I need? 4 times what makes 36? Well, I would need 9 rows. So if I had 9 rows of that, then I would need 9 rows of this, which 9 times 3 would get me 27. So 56% of our students were able to get this. Now, here's the difficult part. Both 3 and 4 are factors of 36, right? So I've got a 4 and a 3 and a 36. What I could have done is, instead of, dividing that 4 into 36 and getting 9, I could have divided that 3 into 36, and I could have gotten 12. Multiply that by 4, and you get your other answer of 48. So labeling is important. We need to know that the science books goes with this first number, science, which is that 4, not the 3. So labeling is extremely important when we're dealing with ratios and rates. And that was that 22% of our students. They did all the right work. They just didn't label it correctly, and they used the 3 in the 36 rather than the 4 in the 36. They got the wrong scale factor. So that was a misconception for us. And so we could have done a table of values, a visual representation. We could have used a proportion. There's so many different ways. Students might gravitate towards one or the other. So we need to show them all the different ways that they can represent this in order to solve.